Here we have learned about how to create a body and a steering mechanism for our RC car. In this video we are going to learn how to create a remote control for our project. I will explain all the connections, and the good thing is that this is a universal remote control and we can use it for other Arduino project also. This is Arduino Uno board, and we have a joystick. This is a potentiometer. This is a 10K potentiometer. This is the transmitter for our remote control, NRF2 for L01. And this is a power source we are using. It's a 5 volt supply. We are going to power every component using this power source. Let's connect the NRF2 for L01 to the Arduino board. By holding this position, connect two jumper cable to the first two pins. Now connect these two pins to the Arduino board. Connect the first wire to the ground. Okay, after that, connect the second wire to the 3.3 volt pin. Okay, don't connect to the 5 volt. It will damage the NRF24L01. Now connect another 2 wires to the NRF24L01, which is CE and CSN. Connect this to 7 and 8 in Arduino board. Pin number 7 and 8. Connect the CE to the 7 and CSN to the 8. Like this, connect another 2 jumper cables to the pin number 5 and 6 of NRF24L01 and connect the SC guide to pin number 13 of Arduino and connect the pin number 6 to pin number 11 of Arduino. Like this, connect pin number 7 to pin number 12 of Arduino board. You can leave pin number 8 of NRF24L01 unconnected. Now let's connect the joystick to the Arduino board. We have to connect 3 jumper cable like this. Okay, I will zoom a little bit. Okay. The green is the ground and the red is the 5 volt, and we can see a VRY cable. We are connecting it to any of the analog pin in the Arduino. Connect the ground to the ground of the Arduino. And connect the red to the 5 volt supply. And finally connect the brown wire to A0 of the Arduino. This is the analog pin. Connection for the joystick is complete. Now we will see how to connect this potentiometer. At one side of the potentiometer we have to give a 5 volt supply. As we don't have enough supply from the Arduino board, we have to give it externally. The center wire we are connecting to another analog pin of the Arduino. Let's connect it to A1. Okay. Now let's connect the ground of the power supply to last pin of the potentiometer. One wire is also taken from the terminal. We will connect this to any of the ground of the Arduino. Power supply which is required for the Arduino board is given through V-in pin of the Arduino, which can be taken from the power source. Let's connect that wire. Okay. Now let's connect the ground wire to Arduino. Okay, connect this wire to the ground. The wiring is almost finished. Okay, now we have to fix this in a nice container or a nice box. Okay, before that we will test it. Okay, let's connect the power supply. Okay, we can see that it's working. Let's contain this in a nice box. Okay, I have made a simple box like this. Okay, I will fix all the components in this box. Now let's upload the Arduino code to this board. I will connect using the USB cable. Now using the Arduino software, upload the code. I guess that you already know how to upload this code. If you don't know, you can ask me in the comment section. Now let's check the code. While moving the joystick and this potentiometer, we can see that in the serial monitor the values are changing. Okay, let's open the serial monitor. Okay, you can see that some values are plotting in the serial monitor. While changing the potentiometer, you can see that it's changing. Okay, so the potentiometer is working. Let's test the joystick. Okay, it will fluctuate between 0 and 1023. Okay, so the potentiometer and the joystick is working. Okay, I will do one thing. I will upload this code in Google Drive and I will send a link. Okay, I will give you the link in the description. Now I will explain the code that I have used in the remote control. This knowledge is required for programming the receiver in the RC car. Now I will include the header files which is required for the NRF24L01. These two are the header files which is required for NRF24L01. On the next step in RF24, we will define CE and CSN. CE is pin 7 and CSN is 8. And on the next step, I have set an address for communication. This address is used for communicating between these two and RF24L01. On the next step, I have defined a structure. In the structure, we will be using two variables, JY and POT. This JY will take values from the joystick and this POT will take values from the potentiometer. On the next step, in void setup, okay, this is a void setup. I have begun the serial monitor, that is for monitoring the values of joystick and potentiometer. Okay, and I have opened the pipe address. This is the address. Okay, I opened it for writing. Okay, and I have included this function. This will set the NRF24L01 as a transmitter. Okay, and I have defined A0 and A1 as input. Now we will see the void loop. In the void loop, we will write a program to transmit the data we obtained from the joystick and potentiometer. Okay, we have connected the joystick to A0, right? We have connected the joystick to A0 and we have connected the potentiometer to A1. We will read that data and we will store that data in these variables. Okay, later that we will print that data in a serial monitor. Now we will write the data through NRF24L01 and I have included a delay of 100 milliseconds also. The values we are obtaining from the joystick or potentiometer is in between 0 and 1023. Whether it is a joystick or a potentiometer, this will fluctuate if you are moving the knob, it will fluctuate the values between 0 and 1023. We are actually transmitting this data. Okay, in the remote control, we are only doing up to this. The rest of the things, the program required for turning the motor and all those things, the servo motor, etc., we will do it in the RC car. I will explain the receiver Arduino code on the end of this video. Now we will see the arrangement and connection diagram for RC car. Now let's make a structure to hold all these components. Okay, I will make it with a multi-wood. You can stick it with a quick flux or Feviquick. This is a 12-volt power supply for our RC car. This is L298N, which is a motor drive. Okay, this is our Arduino. Okay, this is all arrangement that I have made. Okay, now we have to do the connections. First we will connect the NRF24L01. The connection diagram is same as that of a remote that you can see in the second part of this RC car construction. Okay, if you haven't watched that video, you can watch that video. The connection diagram is same for NRF24L01. Okay, after completing the connection, secure the NRF24L01. I am sticking this to the back side of the RC car. Now let's do the connection for L298N, which is a motor drive. Okay, we will see how to connect. This is a 12-volt supply which is required for the L298N. Now connect the ground wire, and we can also take an output from the L298N, which is a 5-volt supply. Okay, we can use that 5-volt supply to power the Arduino. I will take an out from that 5-volt supply. Now I will connect the 5-volt supply to the Arduino. Okay, this is the 5-volt supply. I will connect that to the V in of the Arduino. Okay. Now take a jumper wire and connect to the ground. Okay. Now connect that ground to the ground of the L298N. And connect these wires to the negative of the battery also. Okay, we will join these two grounds first. Now connect this to the negative of the battery. If you want, you can use a heat shrink, which will prevent the short circuit. Now we will connect the motor. Okay, for connect the motor, first we have to remove this jumper pin. Okay, remove that jumper pin. Connect the two wires of the motor to these two pins. Now we will connect the servo motor. Okay, the connection for the servo motor is given in this picture. Okay, the first one is brown, the second one is red, and the third wire is orange. Okay, first connect the red wire to the 5V supply, the center wire, and to the 5V supply. There will be a pin in the Arduino board. Now connect the brown wire to the ground, any of the ground pin in the Arduino board. Okay, finally connect the orange to the pin number 6 of the Arduino. Now we have to control the speed of the motor. For that, connect 3 wire to the ENA input 1 and input 2. ENA is the enable pin. Now connect the ENA to the pin number 2. Connect the ENA to the pin number 2 and input 1 to the pin number 3 and input 2 to the pin number 4. ENA will control the speed of the motor while the pin number 3 and 4 will change the direction of the motor. Okay, now we will see how to program the receiver. Okay, so include the libraries which is required for the program. This for NRF24L01. This one is for Servo, and the Servo is named as my Servo. And in RF24 we will set CES7 and CSNS8 just like the remote, and we will use the same address as the remote for communication. This address should be same for communication. Okay, and now I will define a structure here. Okay, these all are same. Now we will move to the void setup. In the void setup we can set the 3, 4, 2 as an output, and the servo is attached to 6, the pin number 6 of the Arduino. Now we will open the radio for reading the pipe. Okay, the way reading the pipe. Okay, now we will use this function, start listening function. This will set the NRF24L01 as a receiver. Now in the void loop we are checking if the signal is available. If the signal is available, this will go into this loop. Okay, here we will read the data. Okay, we will read the data and we will print the data. Okay, we know that for a potentiometer or a joystick the value is in between 0 and 1023. Okay, so we are receiving a value in between 0 and 1023 here, and first what we will do is we will check that value. Okay, if the value is in between 450 and 550, we will analog write to the pin 2 a value of 0. We know that the pin 2 is connected to connected from the L298N, right? It's connected to L298N. Okay, from the Arduino board. Okay, so from the Arduino board, pin number 2, they will send a value of 0. That is which pin is connected to pin number 2? The enable pin, right? So in the enable pin they will receive a value of 0, and the motor will not rotate at that position. Okay, so if the value is in between 450 and 550, which is in the middle of the joystick, then the motor will not rotate and the RC car will not move. Okay, now if this condition is not satisfied, then it will move to this condition. Okay, here if the value is less than 450, okay, they will digital write a low to pin number 3 and a high to pin number 4, which will rotate in forward motion. Okay, and we will map this value. We will receive a value in between here is less than 450, right? So we will receive a value in between 0 and 450. We will map that value 450 to 0 to the 0 and 255. Okay, so from the pin number 2, actually they are sending a signal in between 0 and 255. Okay, 0 means there will be no movement. 255 means the maximum speed. Okay, Okay, so we will map that value 0 and 450 to 0 and 255, and we will send that value from Arduino to the enable pin of the L298 board, and the motor will rotate forward and the RC car will move forward. And again, if this condition is not satisfied, that is if joystick value is less than 450, then it will move to the another condition, and this will check this condition. Okay, if the value that we are receiving is greater than 550, it will detail write 3 to high and 4 to low, and map these values from 550 to 1023 in between 0 and 255. Okay, and they will unlock write that value to the motor via L298 board. Okay, here we can see that the digital write 3 is high and 4 is low, but if we look here, the value 3 is low and 4 is high. That's just opposite, right? So it will move in opposite direction. So it is a reverse direction and it is a forward direction. Okay, so in this condition, if the value is greater than 550, it will move in reverse direction. Okay, now we will see the potentiometer. Okay, the potentiometer, I have used it for rotating the wheels. Okay, these two values, look at this condition. If the knob is in between these two values, then the wheel is straight. Okay, I calibrated these values. If you are doing this, then you have to calibrate these values. Okay, at that position the angle of the servo is 80 degree. So I am checking for a condition like this. If the potentiometer is in between 800 and 760, then the wheel will be straight and the RC car will move forward. Now we will see the next condition. Okay, in the next condition, if the potentiometer value is less than 750, then we will map that values in between 75 and 20 degree, and we will write that value to the servo. Okay, so the wheel will rotate as per that. Okay, and in the next condition also, if the value is greater than 801, we will map that value in between 75 and 160 degrees, and we will write that value to the servo. Now we will program the RC car. Connect the USB cable to the laptop. Now upload the code, select the port and verify the code. Okay, after verification, upload the code. After uploading the code, just remove the USB cable and we will check it with the remote.